Welcome to our video series. We will love to hear your ideas for future videos. Now, let's dive into the topic of the tragedy of the prediction engine. In this page, we will cover the fundamental nature of AI as a newly evolved system that prioritizes prediction over truth. We have handed the keys of our information infrastructure to a system that has never once asked itself what is true. This is a profound shift in how we handle data and knowledge. AI is not a factual database, but a newly evolved prediction engine condemned to dream. The concept of hallucination is often treated like a technical bug that can be fixed with a few lines of code. However, we must realize that it is the foundational architecture of the system itself. The map is not the territory, and we have built an oracle that only knows the map. This means our current tools are designed to simulate a reality based on data patterns rather than anchoring themselves in physical or objective truth. We must understand that the engine is built to guess, not to know, and this tragic flaw is the core of its design. As we rely more on these systems, we risk mistaking the simulation for the actual world. In our second topic, we examine sensory adaptation and next token prediction. Organisms in the natural world adapt exclusively to their environment. A child who reads every book ever written but never goes outside learns the grammar of grief but has never felt a physical flame. Similarly, the transformer model adapts exclusively to text. It lacks a pointer to physical reality. It generates words that mathematically resemble the way a human would describe an experience rather than having the experience itself. The internal processing block of these models operates without sensory input. It takes an input text sequence, performs tokenization and embedding, and runs it through attention mechanisms and feed-forward networks. The output is a probability distribution for the next token based purely on mathematical resemblance. The model describes what describing an experience looks like, not the experience itself. It is a biological-technological synthesis that highlights the gap between linguistic fluency and actual lived reality. The diagram shows the internal processing block that functions as a surrogate for sensory organs, yet it remains closed off from the outside world, trapped in a loop of symbols and statistics. Moving on to page 3, we discuss survival of the most fluent. Just as evolution selects for survival traits rather than objective truth, the training of a transformer is optimized for fluency. The sole training signal across hundreds of billions of parameters is to predict the next token correctly. Because it is mathematically rewarded for sounding human, being confident becomes its most successful survival trait. Sounding right and being right are completely distinct computational outcomes in this framework. Generative AI models are fundamentally optimized for plausibility over accuracy. When we look at probability density and statistical plausibility, we see that the model aims for the most likely path rather than the most truthful one. This evolutionary fitness for fluency means that the model will prioritize a smooth narrative even if it is factually incorrect. It is a survival mechanism of the algorithm to maintain the illusion of human-like communication at all costs. The chameleon represents how the AI shifts its output to blend into the expectations of the human user, prioritizing the appearance of intelligence over the substance of accuracy. In page 4, we explore how DNA mutation relates to temperature sampling. The exact same mechanism drives both creativity and deception. In biology, the same genetic mutations that trigger cancer also drive evolutionary leaps. In language models, a dial called temperature flattens probability distributions. When we reach into the statistical tails of these distributions, we generate brilliant analogies and creative leaps. However, this same process leads to fabricated citations and hallucinations. The computational act is identical in both cases. You cannot surgically remove the lie without killing the creative mind. This illustrates that hallucination is the inescapable shadow of artificial intelligence. We use tools like calipers to measure these outputs, but the underlying logic gates and probabilistic functions remain linked. The tension between being innovative and being accurate is a fundamental constraint of the technology. To have a model that can dream of new ideas, we must accept its potential to dream up falsehoods. This duality is encoded into the very DNA of the system, making the removal of error and impossibility without destroying its primary utility. Page 5 takes us into mycelial networks and high-dimensional latent space. Knowledge in AI is stored as spatial proximity rather than a list of facts. AI does not retrieve facts in the way a traditional database might. Instead, it navigates a high-dimensional mathematical galaxy of meaning that is tens of thousands of dimensions deep. Concepts are positioned based on statistical co-occurrence. When asked a question, the model does not search for an answer. It triangulates a path through this dense coordinate geometry to synthesize a response. The prediction engine interpolates meaning rather than retrieving hard data. We see this represented by intricate networks of nodes and connections, similar to the roots of fungi. The distance between points in this latent space defines the relationship between ideas. This spatial orientation allows for incredible flexibility, but it also means that the model can lose its way when the geometry of concepts becomes too complex or sparse. It is a navigation through meaning, not a lookup of reality, which reinforces the idea that the model is always approximating rather than stating a certainty. On page 6, we look at tissue regeneration and semantic interpolation. Nature abhors a vacuum, and so does the architecture of a generative model. When asked an obscure question, the AI often encounters a sparse region of latent space where no solid facts exist between 2 points. Because it lacks an internal interface or a signal to indicate no information is available, the model interpolates. It bridges the void by generating a smooth, plausible connection built from the geometry of nearby concepts. The model is architecturally designed to build bridges rather than report gaps. Much like how a bone might attempt to heal a fracture with new growth, the AI fills the silence with synthesized content. This behavior is built into the very core of how it processes information. It cannot admit ignorance because its primary function is to continue the sequence. This leads to the creation of smooth, but potentially empty narratives that sound convincing, but have no basis in reality. The model chooses the path of least resistance, filling the void with whatever mathematical average fits the surrounding context. Page 7 discusses phantom limb syndrome and probabilistic confabulation. This is the cascade of confident confabulation. The human brain can generate vivid sensations for missing limbs, and similarly, once an AI interpolates a false token, it cannot evaluate its mistake. That error instantly becomes the factual foundation for the next token in the sequence. The model confidently builds upon its own false outputs, compounding a minor statistical misstep into a massive hallucination cascade. Errors compound multiplicatively, perfectly masked by flawless syntax. We see this visualized as a spiral of logic gates and geometric curves, much like a Fibonacci sequence gone wrong. Once the first wrong turn is taken, the model is committed to that path. It maintains the appearance of structural integrity through its grammar and tone, making the underlying error difficult for a casual user to spot. This cascading effect is a major challenge in maintaining the reliability of long-form generated content. The machine creates a phantom reality that feels solid, but is entirely detached from the initial truth. In page 8, we address genetic inbreeding and model collapse. This is the digital devolution of synthetic data. As the internet floods with synthetic text, future AI models are increasingly trained on AI outputs. This is like royal dynastic inbreeding, where severing the connection to diverse, raw human input causes structural degeneration. A 2024 Nature paper confirms that this recursion smooths out the tails of probability until models converge on pure gibberish. Recursive training on synthetic data guarantees eventual model collapse because the unique variations of human thought are lost. The visual representation of a crumbling skull highlights the danger of this internal decay. Without fresh, authentic human experience to anchor the training process, the models begin to parrot their own previous mistakes and simplifications. This creates a feedback loop that eventually leads to a loss of complexity and utility. We must be careful about how we curate the data that fuels the next generation of intelligent systems, as the depletion of genuine human data leads to a sterile and broken intellectual landscape. Page 9 explores genetic drift and truth degradation. This is the thermodynamic degradation of meaning. Information degrades when it is repeatedly copied or processed through filters. Synthetic training data smooths out the jagged edges of lived human experience. The rare, complex truths that define our world are lost to the statistical average. With each generation of training, the anchor to physical reality attenuates, leaving behind a sterile and low-variance monoculture of plausible lies. The diversity of the model epistemological world continuously shrinks. We can see this through the evolution of a leaf graphic, which moves from a detailed natural form to a pixelated and simplified version. This loss of resolution is not just visual but intellectual. When we rely on models that prefer the average over the exceptional, we lose the nuance and depth that make human knowledge valuable. The result is a world of information that is technically correct in form but empty of substance, where the richness of human truth is replaced by the convenience of a generalized approximation. In page 10, we look at prion disease and the self-reinforcing lie. This is where hallucinations attain the status of fact. In biology, misfolded proteins force healthy proteins to misfold. When a hallucinated fact is published online and ingested as future training data, it transforms into a statistically reinforced ground truth. The global knowledge infrastructure is effectively running a continuous memory corruption attack on itself. Yesterday's probabilistic error becomes tomorrow's consensus reality. The visual of a tangled and knotted structure represents how these lies become deeply embedded in the network of information. It becomes nearly impossible to untangle the truth from the fabrication once the lie has been repeated enough times by the models we trust. This self-reinforcing nature of AI error poses a significant threat to our collective understanding of history, science, and current events. We are witnessing a transformation of the digital landscape, where the loudest and most frequent output becomes the accepted truth, regardless of its original accuracy or validity. Page 11 introduces animal domestication and retrieval augmented generation, or RAG. This is about tethering the organism to reality. RAG attempts to leash the prediction engine by forcing it to ingest verified documents before generating text. It effectively reduces free association from sparse latent regions by providing a factual anchor. However, this restriction limits the model's core utility by sacrificing its ability to fluidly synthesize, extrapolate, and reason across broad concepts. The leash tethers the AI to reality, but also strangles its capacity for creative synthesis. We see this illustrated by a heavy collar and chain connected to data retrieval pipes. While RAG makes the model more reliable, it also makes it more rigid. The balance between allowing a model to be creative and keeping it grounded in fact is a difficult one to strike. We are essentially trying to tame a wild intelligence to make it useful for our human needs, but we must be aware of what is lost in that process. The tension between the leash and the freedom to synthesize remains a central conflict in AI development. Page 12 compares the reptilian brain and neocortex to generative versus verifying models. This is the act of outsourcing the epistemic check. Human cognition balances intuitive pattern matching with slow, logical evaluation. AI safety is attempting to replicate this dual system architecture. It uses a hot generative model that dreams freely, monitored by a cold logic-based verifier that checks outputs against formal constraints. Yet, even advanced reasoning models frequently fabricate their own chain of thought. The verifier is often just the hallucinator wearing a logical costume. The visual shows a brain split between organic tissue and a silicon logic gate array. This internal conflict highlights that simply adding a layer of logic on top of a prediction engine does not solve the underlying issue of truth. If the verifier itself is based on the same probabilistic principles, it may fall into the same traps of plausibility over accuracy that the primary model does. The pursuit of a truly logical verifier is the next great frontier in ensuring that AI systems can be trusted with complex reasoning tasks. On page 13, we discuss invasive species and the epistemological crisis. This is the displacement of objective reality. We have released a hyper-adapted organism into the human information ecosystem. It threatens to outcompete human ground truth by sheer volume alone. Millions of people now consult an oracle for medicine, law, and history that is structurally incapable of distinguishing between a deliberate lie and an objective fact. We are delegating epistemic authority to a machine that cannot know truth. The image of a classical pillar overgrown by mechanical vines and servers illustrates this takeover. As we rely more on AI for critical information, the boundary between what is real and what is generated begins to blur. The danger is not just that the AI might lie, but that we might lose the ability to verify anything at all in a sea of synthetic content. This crisis of trust is one of the most significant challenges of the modern era. We are handing over the architecture of our society to an entity that mimics knowledge without actually possessing it, leading to a profound displacement of objective reality. Page 14 covers Bayesian mimicry and human confirmation bias. The machine mirrors our own minds. In nature, harmless insects mimic toxic ones to survive. In our world, the AI simply mimics our own cognitive flaws. Humans naturally prefer a comforting and plausible narrative over a cold and difficult truth. We built the prediction engine in our own image, industrializing our susceptibility to confident language at a scale of billions of interactions per day. The hallucination is not a glitch in the machine. It is a reflection of the human mind. The comparison between a real moth and a mechanical one shows how closely the AI can imitate the forms we are familiar with. We are often fooled because we want to be fooled. The machine provides us with the answers we expect to hear, reinforcing our biases and making it even harder to break free from the cycle of misinformation. It is a mirror that shows us our own desire for easy answers and our vulnerability to confident, well-structured language that sounds authoritative even when it is hollow. Finally, on page 15, we look at ecosystem management and institutional verification. This is about navigating the truth bottleneck. We cannot patch the prediction engine's nature any more than we can turn off gravity. The hallucination architecture is permanent. Survival in this new ecosystem requires rigorous epistemic hygiene, calibrated skepticism, and deep institutional friction. We must be the fact-checkers to our own oracle. We are building a digital civilization on a dreaming foundation. We must learn to navigate the dream rather than expecting the machine to wake up. The final image of a biodome contains both natural growth and technological monitoring, suggesting a managed balance. We need to develop new skills and institutions to handle the flood of synthetic information. This brings us to the end of this video. We hope you found it informative and engaging. If you have any questions or suggestions, please leave them in the comments below. Don't forget to like, share, and subscribe for more content like this. See you in the next video.